Yeah, hello everybody. I am Ali Hamidi. I know, Friday afternoon session. I promised to keep it simple, but I also wanted to say that this is my first time at DKNOG. I have spoken to people and I realize a lot of you have been coming here for a lot of years. So I was very excited that I got to come here and present to you and yeah, get to know some of you. So who am I? I am Ali Hamidi. I work as PLM Optical Solutions at a company called Smart Optics. We are a Scandinavian company with a global reach. That means that we develop optical networking equipment and network management software solutions. So today I will talk to you about software-defined networking for control, management, and automation in disaggregated open optical networks. So just an outline of the talk. Initially, I will explain what is the fuss about, what is open and disaggregated optical networking, why is this a strong trend, what are some of the challenges, and some of the industry initiatives in this field. And then we will cover the details of software-defined networking. We will look at some of the different aspects, full disaggregation, partial disaggregation, and then the single domain, multi-domain, some commercial uses, and what's the way forward, the future. So yeah, let's get started with that. Yeah, before we jump into the open and disaggregated part of it, let's revise the traditional way of doing things. Well, traditionally how things have been dealt is that you get in touch with a single vendor that helps you to build your entire optical transport network. And what that means is that everything is vendor specific, it's vertically integrated, and proprietary based. And that's the same for the network controller as well. That means that for when it comes to management and control, you have closed APIs, and you also have vendor specific data models. When it comes to disaggregated building practices, interoperability is the key, because this allows operators to mix and match. You can buy equipment from different vendors. Disaggregation allows you to separate the layer 0 and the layer 1, and also disaggregation from or separating layer 1 from layer 2 and layer 3 allows you to buy switches or routers from the vendor that fits your needs best. Similarly, when it comes to management of these network elements, you have open management, where the use of open APIs, standard APIs, and common data models enable you to allow and control and manage these optical networking elements. So why has this become a very strong trend? Well, faster innovation. We yesterday heard talks about coherent transceivers. You see how the technology is developing. 400 gigabits, 800 gigabits are not too far away. So this allows you to separate the life cycles. And if you separate the life cycles of layer 0 equipment from layer 1, then the transponders can keep up with this development on the coherent transceiver side. Cost savings, which are very important. And this is possible because of the strong competition. You have the possibility to choose. The vendors have to compete with each other. Best in class features. You, as an operator, have the possibility to choose that vendor that provides the features that you need or would like to be employed in your networks. Flexibility. You're not locked in by a single vendor. You have the possibility to choose based on technology and based on features. And ultimately, simplicity. Control, integration, and management using one SDN system. So these are some of the trends which are driving this network disaggregation, but it comes with its own challenges. In the last couple of years, a lot of proof of concepts have been done in this field, and more are ongoing. So we have solid track record from real-world deployments, but more interoperability testing is needed, because ultimately, this is what the whole thing is based on. You also have integrational challenges, and also when you're going to build a network where different parts of the network has equipment from different vendors, you will have some sort of operational efforts that you would need to, from your side, to integrate everything. And what are some of the initiatives in the industry that are driving this? Well, you have the Open ROADM and the Telecom Infra project. They are both consortiums that consist of both vendors and operators. We, being a network equipment provider, we're also part of the Open ROADM that focuses on interoperability when it comes to ROADMs, optical transceivers, and transponders. Also defining common standard YANG models which enable this interoperability. Then you have the Telecom Infra project. In that one of the most interesting one from an optical transport standpoint is the Open and Optical Packet Transport Group. And once again, this one is also defining technologies, architecture, and all the interfaces that you need for disaggregation to work in an open networking environment. And lastly, the open config and optical networking. So ultimately, one has to remember that interoperability is the key, and focus of all these initiatives is to enable interoperability between networking elements and to allow open management of and control of these networking elements based on standard APIs and open interfaces. So where do we stand? We, Smart Optics, what is our philosophy? Well, we believe that an open line system should be based on open and standard APIs. It should be able to support any combination of embedded DWDM or transponder or muxponder traffic. There are no alien wavelengths. You should be able to support all of them. And no extra licensing costs when it comes to increasing capacity or adding new wavelengths or expanding to higher data rates like 100 gigabits per second or 400 or 800 gigabits in the future. Also, IP over DWDM is a concept that we have been championing for a long time. And of course, full monitoring capabilities are very important. So this is our philosophy. This is how we design our products and have been doing it since the beginning. Moving on. Now, when we have learned about optical openness and disaggregation, the interoperability and the possibility to mix and match, where does software-defined networking come in? Well, everything started with the question, why shouldn't networking devices be programmable? Because it should be possible that if you're using a software controller, then by using standard APIs and open interfaces, you should be able to communicate with networking elements, and you should be able to configure them and manage them and monitor them. Well, what do we mean by that? Well, configuration involves things like resource discovery, service provisioning, fault analysis, troubleshooting, and monitoring, performance monitoring especially. What are some of the controllers that can do this? Well, there are many. You have the open source controllers like UNOS, ODL, but then there are also vendor-specific proprietary-based open controllers that can do the job. But ultimately, the requirement is that the SDN controller allows separability of the control plane from the forwarding plane. So you should be able to control and manage your networking elements through the use of these open interfaces and standard APIs. When it comes to open disaggregated transport networks, there are two types. You can have full disaggregation or partial disaggregation. Well, in a network, you will always have your layers. You have the service orchestration layer, you have the network management layer, and you have the disaggregated network or the infrastructure layer. This is where your optical transport network is, your transponders, your muxponders, and your optical line systems. And full aggregation means that the SDN controller should manage each networking element individually, including your optical terminals and optical line systems and every component that's part of the line system, like multiplexers, demultiplexers, inline amplifiers, and ROADMs. Partial disaggregation. Well, partial disaggregation is an improvement on the full disaggregation in the sense that it allows you to decouple the life cycles of the optical terminals and the optical line systems. So both of them can be managed independently. This also allows you to buy equipment from different vendors. You can buy OLSs from one vendor and optical terminals, transponders from another one. And you can also buy transponders from multiple vendors in the same segment. But ultimately, it's this control and management that comes in that's made possible by the use of open APIs, both in the southbound direction, where the controller is communicating with the devices, and also in the northbound interface or direction, where you're communicating with the higher order hierarchical SDN controller. And even within partial disaggregation, you have different concepts like single domain vendor segment when it comes to the optical line segment. So you have, what does that mean? That means is that in the optical transport network part of your segment network, you have your line systems coming from a particular vendor. And we have been talking about the use of open APIs and standards. So what are these? Let's talk about them as well. Here you see some of the examples. When it comes to managing or communicating with the open line systems, you can use netconf, which is a standard protocol for this purpose. GNMI can be used, vendor-specific protocols can be used, as long as the networking element supports open standard common models. On the open terminal side, OpenConfig is one of the commonly used examples for this purpose. And the network itself contains all the networking elements that can be managed independently. But it's not just restricted to the single domain concept. You can also have different parts of your network where you buy equipment from multiple vendors, so that in one of the segments you have your open line segments from vendor X, and in the other part of the network you have open line systems from vendor Y, and the whole thing comes together through this hierarchical SDN controller, because it's this hierarchical SDN controller that here allows control and management over multi-domain DWDM channels when you have several layers of open line segments. And this allows you to provision traffic and set up control and management of the network when a command comes from the orchestrator from the upper layers. So what are some of the platforms that allow you to do this? Well, one of them is ODTN. It's an open source software platform for control and management of the network. You see the different layers. At the bottom, you have your infrastructure layers where OpenConfig is used for the control and management of your transponders. And then the open line systems are managed by TAPI, the transport API. And then in the northbound side, you also use RESTconf-based protocols, which are part of TAPI. And the SDN controller, or the UNOS, is the network operating system that allows you this control plane and this separation, and then control and configuration of your network. And everything is, of course, based on standard and open APIs. Another example is Open Daylight, which is also a modular open platform for network management and automation. And if you look at Open Daylight, it's actually Transport PCE, which is the SDN controller that can be used for controlling the ROADM control application. And in Transport PCE, so Transport PCE is the one that allows you this control. And what do we mean by this control again? Once again, it's configuration of the optical networking elements or the transport equipment through non-proprietary southbound interfaces. Well, some of the commercial use cases, like I said in the beginning, there are many initiatives and there have been many proof of concepts that have been done recently in the past couple of years. All of these have been made possible due to this SDN ecosystem, that you have these open standard APIs for both southbound and northbound interfaces that allows you this control and management and automation of the networking elements. Partially disaggregated optical systems seems to be the trend, because it has become, looking at the trends in the industry, it's clear that this is the preferred architecture as desired by the operators. So most of the, and one of the reasons for that is it's much easier and less complex to manage compared to full disaggregated scheme. And then also more collaborations between vendors is ongoing and needed to align APIs and integrate these solutions. All of these are key to SDN operability. I talked about some of the commercial use cases. TIP, the telecom infra project, is one of the common one that comes to mind. They're very committed and focused on building open disaggregated networks. They have many project groups. I talked about the open optical packet transport group in the beginning, but then you have other ones as well, where you have the mantra, and you have the mandatory use for SDN transport and many others. And the whole idea is that you should be able to, regardless of which part of the network you're in, you should be able to make disaggregation and open optical networking a possibility. So now, like I said, it all started from the question, why should network elements not be made programmable? Now we have learned that they can be and are actually programmable based on the use of these open and standard APIs. So what's the future? Well, the future is, of course, network automation, which requires zero-touch provisioning. And also, with the use of network analytics, streaming telemetry, and using AI and machine learning, we can actually get network control and automation in place. And what is it that we want when we talk about network automation? Well, transmission performance optimization. This is, of course, one of the critical parameters. And also, looking at the data, when you have the data, you should be able to predict when failures are going to happen. Traffic prediction, how are you going to set up traffic in which part of the network? Network maintenance, but also performance monitoring and optimization. This is the future, and this is, I'm sure there were some talks yesterday where you probably talked about these things in detail. I just wanted to mention that before we conclude. Thank you.
Thank you, Ali. Do we have any questions? Thank you. Well, thank you again.
Thank you.
Thank you.